Hello, everyone. My name is Patrycja Wegrzynowicz, and it's very nice to see you here at my talk. I'll be sharing my experience working on highly available and resilient connectivity across three clouds, AWS, GCP, and Azure. Briefly about myself, olá, and that's all what I can speak in Portuguese. And actually, that's the very first time since long time when I speak at live events, so please don't be too harsh in judging me. So briefly about myself, I've been doing professional software development for over 20 years, and my first love was programming. And only almost a year ago, I joined the dark side. I became platform engineer, and I must say that I do enjoy it. I joined for free, and I worked there as senior platform engineer, building their new platform for agenda. What am I gonna talk about today? So first, I would like to explain why at all we need multi-cloud connectivity. Then I'm going to show you some demo why such connectivity and highly scalable, resilient platform may be useful. I'll be talking around various connectivity options like VPN, like cloud exchange providers, like private connectivity. Then I will move to Kubernetes and CNI, but only a brief overview because Kubernetes networking is such a big topic that I couldn't squeeze into this short talk about so many other things as well. And along the lines, I will show you some performance results of our connectivity and our tests in multi-cloud setup. First, I would like to explain you some context. Form 3, in 2 words, may be called financial cloud. Basically, Form 3 is a company which provides a payment platform for other financial institutions. It makes easier integration of multiple payment schemas. This way, it saves time and money for banks or any other payment processors. What is underneath? There is a pretty complex platform. We are fully cloud-based. At the moment in AWS, we work with microservices written in Java and Go. And we have chosen Terraform as our infrastructure as code tool. What are the challenges of payments processing? First and foremost, reliability and durability. That's the most important. We can't afford to miss any payment. We can't afford to have like a longer outage. Our clients, our customers need like 24/7 processing without any outages. Also, we need to take into account volume of payments which we process, which is still increasing. Plus, on top of this, we need to provide high security because when it comes to money, it's always important to be secure. And think only about some outages last year around cloud providers. Did any of you experience some issues because of one of those outages? Raise of hands, please. Yeah, oh my God, it's like half of a room. Yeah, that's a lot. I didn't expect this one. But when I was looking through this list, by the way, prepared by TechGenix, so when I looked through this list, I remember that I was hit by number 4. Because besides my regular job, I also teach at Warsaw University. And this was COVID time, so we had like a Discord server just for some consulting or remote teaching, etc. And it was during this consulting hours when this started. We managed to check that we first experienced some slowness, but then it was like totally unavailable. So yeah, so it happens to all of us. So I don't need to convince you that we do need diversity in our platform. That's why in Form 3 we are going multi-cloud. We are working on new payment platform. Obviously, it has all those capabilities like high availability, resilience, scalability, etc., etc. And this time we really need them because I used to work on some systems that, yes, we were told by clients that how critical their system is, but eventually it never happened to experience any high load or some critical situations. So for us in payments processing, it's important to avoid any outages and to ensure that we can recover from almost any disaster. That's why we decided to go and use, instead of only AWS, to spread our platform to GCP and Azure as well. That was and still is quite a significant challenge because obviously when you work with one platform, you use cloud-specific solutions like, for example, AWS SNS queues, S3 buckets, RDS, etc. Here we have to switch to cloud-agnostic technologies that work around many clusters, many clouds. We decided to use as sort of like high-level overview Kubernetes with NATS and CockroachDB. But to make all those tools work, we need first and foremost connectivity, right? Without connectivity, we don't have anything. So that's like a backbone and heart of our platform to have reliable and fast connectivity. I won't show you very fast connectivity at the moment because I would like to show you why this connectivity is important and how we can survive any cluster disaster once when we go multi-cloud with a proper set of tools. So for my local demo, I will use only VPNs, but we don't need a very high speed at the moment. Just to show you how it may work. So first of all, my setup, I have 4 clusters available. The first one is in AWS. The second one is also in AWS. The third one is in GCP. And the fourth one is in GCP as well. I had my Azure cluster almost ready, but you know how it happens with live demos. And Azure is pretty chimeric, I must say. So let me be on the safe side and use only AWS GCP, but instead 4 clusters. And I based my demo on a very cool demo from Isovalent. Isovalent is company behind Cilium. And Cilium is a CNI plugin. Basically, it helps in connectivity and provides some extra feature on top of it, like security, encryption, and that kind of stuff. And one of the most important feature, global services. So basically, Cilium can transform a regular Kubernetes service into global service, which is load balanced across many clusters. But in order to have something like this, first we need to mesh clusters. and prepare kind of cluster mesh with Cilium. So this cluster mesh is up and running already. And the theme in demo is Star Wars. So I slightly modified the original demo by Isovalent. So we have our first cluster. Let me board my X-Wing. Hope it works, and connectivity, yep, it works. And fortunately, that's only, unfortunately, that's only Wi-Fi, but fortunately, it worked. Okay, so we have X-Wing, and we can try to locate Rebel base. So let access service. Yes, we have. It seems that it's done to in, which is on GCP cluster 3. Let me show you how it's gonna work when we ask many times. I must say that speaking and writing is not my highest skill, but I think I haven't made any mistake. We'll see. Nope, I do. I've forgotten about Carl. Yep, it's here. And now we are good to go. Nope. Yep, done. Yeah, thank you. That was fantastic to have such help from you. Because you know how it is. When you look for it yourself, you never see it. But we see here a lot of clusters. Not so many, only 4 of them, but we see that the service is load balanced, right? So we have Alderan, Dantuin, Camino, and Form 3. So maybe we'll try and help Form 3 to win over the Galaxy, right? Let's scale down other services. So I'm afraid to write at the moment. Oops, actually, that was not my goal. I was about to scale it down to 0. Okay, so we should have only now 3 clusters. It seems so, but we need more time to observe. But in the meantime, let me switch to 3rd cluster and let me scale it down as well. So now, oh, it's not scaled down yet. It is now. So now we should have only like 1 and 4. Yeah, it is. So only 2 on the battlefield. And let's switch to the 4 cluster and scale it down as well. Oh, we seen a short blip. It may happen, but we have like still 1 cluster. But we have something like, let me start it once again. Yeah, it always happens with the demos. Let me log in once again, because sometimes there is like a network blip, and with Wi-Fi connectivity, I'm not sure how it works. Oops. Let me see. C1 server. You know, I never experienced this one, but there is always first time for everything. So it seems that we have X-Wing up and running. Okay, now it seems fine. I don't want to be so greedy, and I don't want to leave form free ruling the galaxy. I would like to share it with others. It's always better to have more diverse environment. So let me see. At the moment, it's only form free in the galaxy. So let's scale back one of other servers and let's make it running to replicas. It takes a bit of time to start up, but in a moment it should I'm not sure. Oh, I was at one. I was at the first cluster. See here, I changed my context to C1 again, so it was like no op at the moment. So let's switch here. We are at cluster 2, and now let's scale up our second cluster. The second cluster is AWS again, and we see it, yeah, fortunately. So with a couple of hiccups, we made it. That's good. I hope that you enjoyed the demo. At least you see how Cilium global services work, and usually they work better than it was during the demo. But you know the Murphy law. So that was Star Wars demo. And now we can move to how actually we can work toward making it real-life experience. So when it comes to requirements, I'm not sure, but it's always to be fast, right? It must be fast for connectivity. 4 years, I'm not sure. Maybe in the sense that this connectivity should meet all our sometimes insanely high requirements for our platform, and it should provide us safe landing. So we need to be secure, and we need to know that our solution is feasible. And when it comes to real-life requirements, obviously low latency. We want to cluster across many Kubernetes instances. So it means that we need to replicate some services, like for some data, like for NATs or for jet streams. And for some of those services, we must provide synchronous writes. So that's important. We need to have a steady bandwidth. We need to know what we stand on, right? Plus, with payments, as I told you, security and privacy is always an issue. Also, we need to provide high availability setup and fault tolerance in case of failure on any level. So being it a link, a device, a point of presence, etc. So we came up with 3 options. virtual private network. This one is pretty easy to set up because that's like an encrypted tunnel over public internet, and all major cloud providers, they offer similar services, usually with high availability setup. Another option we thought about and we were very close to choosing was direct connectivity via cloud exchange provider. So there is some companies that allow you to buy basically a connection, rent a router or something like that. So basically that's a network as a service. And we could buy like direct connectivity and route it via virtual router to another cloud. And such an example is is Megapod, is such company we tested and we almost used. But eventually we decided to go with direct connectivity via data center. That's a very similar setup like with using cloud exchange provider. But instead of virtual router, we have a physical router in a physical data center we operate. So let's go through some pros and cons for those solutions. So when it comes to virtual private network, as I told you, it's really easy to set up. I told you that at Form 3 we use infrastructure as code almost as a religion. So that was very important for us that a solution guarantees such terraforming. In virtual private web network, we don't have any third-party dependency. That's always good. It's always a problem when you need to deal with many vendors, right? So that was our pros, but we ended with a very long list of cons. First of all, higher and unpredictable latency. Obviously, this connection goes through public internet. You never know what you'll see in World Wide Web, or maybe World Wild Web. So it depends on situation. Routing may go other way, other path, and we end up with some spikes in our latency. So with routing, with unpredictable routing, there is another problem. When it comes to sensitive data, there is some regulatory requirements sometimes that they can't leave some zone, a country or something like that. So for example, for a GPRD privacy issue, your data can't go for example, outside European Union. And with public internet, you never know how your packets are going to be routed. On top of this, we have like unpredictable bandwidth as well. Again, the same case as latency and routing. And basically as our primary solution, it was never an option. We considered VPN as like our secondary backup option. And with such assumptions, another con was that it would be more difficult to configure automated failover combined with other solutions. So we did quite an extensive and deep research around cloud exchange provider, but it's like a very shady area. You never know what they have underneath the API, or if they ever have an API. Sometimes it's like only a shady web page, so that was a no-go for us as well. That's why we took a deeper look at Megaport because it provides a Terraform provider. So we tested with our Terraform solution, and it worked. And it worked pretty well. However, we experienced some problems. The problem was we were investigating high availability setup with Megaport connection and Megaport virtual router. And that was a problem at the time for us because we were interested in London region. Our platform is gonna be based in London region, so we needed 2 points of presence and 2 routes to every cloud in London. And unfortunately, at the time, Megaport didn't provide it. Their backup route to GCP, as far as I know, was going to Frankfurt. So that was like, again, a very long latency. We couldn't afford it even as a backup. So that was no-go. Another no-go was that as company involved in the finance world, we sometimes need some clearance, contractual agreements, that kind of things. And with Megaport, it was difficult to get them audited. It seems they were not interested in security audits of any kind. And that was like contractual obligation for us. And they didn't offer any special enterprise class support for us. Again, when something's happen, we need to have like a support to go to, and the support needs to work 24/7 the way our platform does. So that was no-go. So we explored an option of direct connectivity via data center. We are more like a software company and involved in virtual cloud world. So we don't deal with hardware on daily basis. But we have like a very good partner. Host operator and data center operator, which takes care of our hardware for us. So that was a plus because we had someone to talk through our possible solutions and directions, and we had someone to trust through. Plus, with direct connectivity, one more drawback of Megaport was that, as I told you, for some regions, we didn't have like 2 different routes available to some cloud provider. Here with direct connectivity, we are more flexible because we can go to another provider and we can have some connections from one and others from another provider. So that's more flexible. Obviously, we have good predictable latency with bandwidth and secure private connectivity. Unfortunately for us, we have a problem because infrastructure as code is not possible, fully possible at least, because our routers, hardware router, physical routers are managed by our partner, our vendor, and they don't do Terraform. So plus with some hosted connections or hosted virtual interfaces, in both cases you have problems with monitoring and observability. So that's a problem. But on the other hand, we don't have problems with clearance, security clearance. That's very important for us. So that was our way to go, direct connectivity via data center. And I must tell you that we succeeded. And actually, it was a couple of months ago, we managed to make it working. However, it took like 2 or 3 months to set up all the things, especially those discussions with our vendor were time consuming and quite exhausting. On the other hand, it works very fast. We don't observe any blips, which we observed on one megaport link. So again, that looks much better, and we have predictable latency. I will show you some tests later on when you have like some connection anomaly with some solutions, and we don't want this one. So on very, very high level, we have like redundancy to, we have 2 data centers, we have redundant connections to every cloud, we have redundancy and HA setup for direct connect, interconnect, or express route. So that looks pretty neat. When it comes to more detailed diagrams, it differs per cloud. If you are familiar with a couple of clouds, you know that their naming, their wording is different, their concepts are a little bit different, even though underneath, in case of connectivity, it boils down to, usually it boils down to some sort of a router with BGP. And dynamic advertising. So I think that AWS is the one which has a lot of those individual elements you need to connect in order to establish connectivity. Obviously, we use transit gateway. We have VPC attached to this transit gateway. Then on the other hand, we have direct connect gateway, which routes to 4 virtual interfaces. We have redundant interfaces, 2 redundant interfaces per connection, and those goes to different data centers. We have some naming around clouds as well. You see that in terms of elements being used, GCP is definitely the winner. And it was really very smooth configuration. On the other hand, Azure was, I was going to say our pain in the ass, but maybe I should say like the most challenging one. So with those long provisioning times, different broken peerings that happened till this time, and basically that's the beauty of Azure. Plus, unfortunately, we had to change our BGP configuration on our data center routers for Azure because Azure doesn't support custom CIDR advertisement, so you can't set up custom CIDR to be advertised over BGP. It only advertises connected virtual network CIDRs. And that was a problem for us because we had like one big CIDR range set up on Azure side, and our routing in DC was configured to do exact matching. So it didn't work this way. We had to change it to or longer, so just to have more flexibility. Okay, let's move to some performance tests. The performance test we did with free tools, and actually there is a very neat setup on GitHub with Kate's NetPerf. It includes free tools, iPerf, NetPerf, and Fortio. And iPerf was used to assess throughput, as well as like to detect some blips or issues with connectivity. It provides quite good tooling. NetPerf, on the other hand, has a very good set of various metrics and various tests. We focus on TCP RR and TCP CRR tests. RR stands for request response, and CRR connect request response. So basically, TCP/RR is for use cases when you have a long-lived connection and you do many requests over this one connection. CRR is for cases when you have like make a connection per request, basically. So this also happens sometimes, but less common. And for Forgio, we want to have some more higher level results for different HTTP protocols. Maybe HTTP 1.0 is like a historical one at the moment, but for like awareness, custom awareness, it was good to learn how big is the difference between HTTP 1.0 and the next versions. 1.1 is, I think, the most common one. However, we are switching to HTTP 2. We as a world, there is this common switch to HTTP 2.0 or higher, and gRPC uses by default HTTP 2. So here, in this case, again, what was interesting, latency and throughput. Let us see some results for VPN, multi-cloud connectivity, and in two modes, node-to-node and pod-to-pod. Node-to-node is basically your baseline. When you have like Kubernetes on top of it with its custom networking, it's like an extra layer of abstraction, and when it comes to any performance problem, they say that you can solve any performance problem by removing this extra layer of abstraction. So fortunately, it looks like in this setup we don't have any particular difference in node-to-node and pod-to-pod results. It's almost the same. Those graphs looks very similar, and you always have some like small differences. That's like normal. When it comes to VPN and DC, here you have like AWS GCP with VPN, and just right on the right you have AWS GCP with DC connectivity. So here you see a huge difference, maybe not in P50 or P90, but P99 it's like half of that on VPN. That's again what I was talking about, the result of this unpredictability of VPN. And we can see here that GCP basically has some problems with networking in London region. With GCP, we always get highest results. We see those one in VPN. DC private connectivity is much, much better. Again, I think that's like 30% more speed and less latency in case of DC, but still comparing to other pairs like AWS Azure and AWS GCP, those are better. And here you see like an anomaly. I had to rescale this diagram because that's the result of one of our tests when VPN was like between GCP Azure skyrocketed basically. It was on average it was around 50 millisecond. That's a lot, and that's like not acceptable in case of clustering of any kind. In case of latency latency we we focus on pod-to-pod connectivity at the moment because that's our target one. As I told you, we don't observe much difference between node-to-node baseline connectivity and pod-to-pod on this one. One more important thing, all those tests were done with, till that time, were done with original CNI, Cloud CNI specific plugin. So no extra plugin here, only the original cloud setup, and it performs very well. So if you don't have any specific needs, you don't need to use any other CNI plugins. You are good to go with what clouds have to offer. But let's move to Kubernetes and CNI just to go over very, very briefly on very high level about Kubernetes networking, just for you to realize that nothing's for free. So we have very good baseline connectivity, but on top of this, we have many protocols, and each one of them and each tool adds extra performance overhead. And Kubernetes with its custom networking is very specific because Kubernetes have very specific requirements on how containers must behave in terms of networking. Each pod needs to have its own IP. This own IP must be visible to other pods, must be routable, and the pod itself must see this IP as its own. And basically, that's the responsibility of container network interface plugin to take care of IP assignments and take care of routing from one pod to another. And think about this one, that's not that simple because it needs to go from one, in many cases, it needs to go from one node through host network to another node. So each cloud provides its own cloud-specific plugin. With clouds, you don't have access to configure your network as you wish. You need to adjust to cloud-specific security requirements and basically just not to mess up with routing and networking for all the cloud. That's why we have such limitations. We have those cloud-native plugins which perform really well. I was really surprised because what I was told before is that you need to go with, for example, Cilium. Because Cilium supports eBPF. That's like sandbox code on kernel level, and they do routing that way. So it must be faster. It turned out it's not that faster, or it's not at all. We didn't see any difference in performance. Why? Because again, Cilium in clouds has very limited configuration options. And for example, we can't configure eBPF host routing. We need to use legacy mode because basically clouds don't allow on such routing modes for CNI plugins. When it comes to CNI plugins, we have generic ones which can be used in clouds or on your bare metal machine, Kubernetes. There is a couple of them. I think that the most popular one is Calico. we are in the process of testing Calico, so we don't have performance results for Calico yet, but we are focusing on Cilium because Cilium was used by one of our teams and they were pretty happy with Cilium configuration. They had they needed to use custom plugin because they have clusters in data center and they have clusters in cloud. So in data center, basically you need to configure some custom plugin because otherwise it won't work. Networking won't work. So Cilium is pretty interesting when it comes to features. It's very rich in features. However, it's very difficult to configure. We have many knobs and puzzles around configurations. Basically, the most interesting features of Cilium is Cilium cluster mesh with global services. You've seen during demo one example of such global service. So basically, it's like one service across balanced across many clusters. A small problem, or actually in production usage, it might be a big problem, is that at the moment Cilium supports only round-robin policy with load balancing. So, for example, if you invoke a service from cluster, you can end up with another one. There is no affinity towards a local cluster and local service. So in terms of performance, it might be a performance kill in some cases. So that's not best, but they told us they are working on new features. Finger crossed, they are gonna be released very soon and they're gonna be in a good shape. Another important feature for us, it was network policies. Cilium supports identity-based network policies, so we don't need to focus on IPs. We can assign like more logical names, identities to our services or other elements, and we can organize our security rules around those identities. So it's much smoother and it's easier to manage. So that's important. Plus they provide some network policies in L7 layer, which is also very important for us. On the other hand, one thing they were famous of, encryption, it didn't work for us very well because our pen testers, that's pretty good team, they discovered that Cilium doesn't encrypt traffic inside one node. So when two pods are on one node, this traffic between those two pods won't be encrypted. And again, that's a no-go for us because our goal was to use Cilium encryption as encryption in transit, and we can't use it that way because there is like a moment when data are not encrypted, and that's not a good solution in terms of financial services. Another thing they try to go with is pod IP routing, that they provide pod-to-pod connectivity. However, in terms of clouds, with cloud-specific CNIs, you get this for free. At least with Azure, AWS CNI, the tests you've seen, they were like pod-to-pod tests without any extra CNI, and this direct routing just works. With Azure, there is one problem because we need to configure Azure CN9 instead of default kubenet. So there are some neat use cases, but let's move to latency and Cilium versus cloud-native routing. When you take a look at those figures, they are very similar. Again, AWS, GCP with Cilium and cloud-native CNI, they look almost the same, and that's the case for other. So on one hand, that's good for cloud-specific CNIs, and we see that with cloud limitations, Cilium doesn't shy as with bare metal machines and custom Kubernetes installations. So that was like very quick go through our journey to multi-cloud connectivity. As you can imagine, there were a lot of traps on this way, but we managed to go through them in one piece. So we are happy. But on the other hand, we've learned a lot. And we've learned a lot that we need to use our tools wisely, because a fool with a tool is only a fool. And we need to know our tools. And that's my piece of advice to you. Know your tools better, test, and make your decisions based on tests and data. That's very important to understand what's going on in our IT systems. So thank you. We are running out of time, but I'd be happy to answer any of your questions during break time. And tell me about your journey, whether or not you are interested in going multi-cloud. Thank you.